I'm going to put your faces closer to where my camera is so it looks more like we're looking at each other. There we go. And I'm going to see if I am advanced enough to operate this slide view. There we go. Hey, look at that. Okay, so as my intro slide there said, I'm currently principal software engineer at MassChallenge. Anybody familiar with MassChallenge in the room? Feel free to use the hands. I'm going to put you all on a grid so I can see more faces, more faces and hands. There we go. So if you at any point you have a question, or something's, one of my kids ran in the back of the room and is jumping on the bed or whatever, just let me know by raising your hand. So thank you, Tyler. So I'll try to keep this down. I've been known to make this overlong because I love my work so much that I want to talk about all the fun stuff that I've been able to do, but I'll just try to keep it to things that relate to my Python credentials. So the 5-minute resume goes something like this. I used to be a freelancer, and many Nerd Summit folks are freelancers, which is a great life. I love the lifestyle. I love my clients. I was terrible at the business part, so I moved on from it and got a quote unquote real job at the end. But I had some very cool clients regionally and got to work on some neat projects. So that was fun. And one of those projects led to a full-time job at the Hallmark Institute of Photography, which is based in Turner's Falls. It's no longer in existence, sadly, as a sort of victim of the recession, plus the digital photography revolution, plus the owner being convicted of financial crimes. But a great education for sure. And it was a great opportunity for me to be able to really take the lead and sort of do it as I saw fit in terms of building apps for the business. I came in, they needed an attendance system, and I built something for them in FileMaker originally, but then it had reporting that was basically in Python as I was sort of transitioning to Python at that point, and ended up converting the whole thing into a Django web app that ran locally on our servers and had kiosks that were retired iMacs that had barcode scanners attached to them, and students would go in and they would tell them happy birthday was their birthday and give live attendance reporting to the administrators and good stuff like that, and various web apps too, like a social site for alumni and other things. Since the school went under, I was able to make the software open source. So the upper right screen grab there is the GitHub repo of the system that more or less controlled all the class scheduling, attendance, and things like they had a lending library of about $1 million worth of photo equipment, and that was tied into the student database for obvious reasons. So that was super fun. While I was there, I started this pastebin site called dpaste.com. It's one of my longest lived side projects. I've retired many of my side projects, but this one lives on. It's a programmer pastebin like pastebin.com or GitHub gists. It has two things that motivate me to keep it going. One is it's built into the Django web framework. So if you get an error page in Django, if you're developing a Django site, and there's a button there that says share this traceback on a public site, that goes to my site. It's kind of amazing to me. I wouldn't run a project that depended on some random guy's pastebin out in there, that's as high profile as Django. But I've worked hard to keep this thing up and running, so it's a very fun project. I have some of my code examples later in the talk are drawn from this project, so it's still going strong, and of course everyone should use it. Along the way, I also co-wrote a Django book. I was using Django a lot, and this was early days of Django, and I was very active in the Django IRC channel for answering questions. People coming to, I did this, and it's weird, and this thing broke, and there were a few of us who were really mainstay Q&A people in the channel. And one day, one of them reached out to me and said, "Hey, Paul, I was asked to co-write a Django book, and we need one more person. Do you want to do it?" I was like, "Hell yes, I do." I had writing experience before. I had been a tech writer, and I was a teacher at that point as well. And it's like, this is a perfect fit. Let's do it. And so I co-wrote one of the first Django books. I think it's actually still in print. Don't buy it. It came out in 2008. Why you would, why is it still available? I don't know, but I get like a $30 royalty check every 6 months. It was super fun to do though, and it was a great great calling card. I recommend it if you have an inclination and you have a chance to write a book. You don't make a lot of money from it, but it's a great calling card. And it's also, as anyone who's sort of written instructional material knows, you learn stuff as you have to sort of spell it out in detail. Then, pardon me, the photography school started closing down, laid me off, and I went, at that point, I transitioned to being a full-time engineer. Before that, I had been a writer and an engineer, or a teacher and engineer, or some combo, or business owner and engineer, but now I was just going full bore. And I got hired by a startup that was, this craze has kind of died down, but circa 2010, there was this penny auctions thing, Cactus and Quibids, and there were a bunch of these things. And it seemed like it was a way to print money. And so some enterprising young entrepreneurs in Miami actually fired up this project, and they needed more Django developers, and they hired me. They went out of business. They're a startup, so they took a risk and they didn't make it. But it was a fun project, and introduced me to a lot of stuff that then paid off. That didn't last long because they burned through their money. But then I transitioned to working for a giant media company based in Atlanta. They're called Cox Media Group. They got 100 newspaper, TV, and radio properties around the country, and they were in the process of building out a web publishing system to serve all of them. They had previously done various sort of ad hoc or vertical market things. They wanted a all-in-one solution, so they were just building up this team of Django and Python people, and they ran out of talent in Atlanta because they were growing so fast. And so I was one of the earlier remote hires, and by the end, about half the team was remote. So that was also my education in what makes for a good remote team and remote software development operation. And I learned a lot there about scale. When people who don't really use Python like to complain about how slow it is, or people who have to use it but would rather not. We were serving 40 million pages a day on top of a Python web application. So it helps to have Akamai serve 90% of them, but nonetheless, Python's not the problem. After that job, I transitioned for a bit to working for a translation services company that had an app that was basically just a giant API. It was all, if you've done Python APIs, it was all Django REST framework. And it integrated with things like big company CMSs. So let's say that FedEx had some new training materials and they needed to translate them into 6 different languages. Somebody in their corporate could press a button that said submit for translation, and that system would talk to our API and put in the job. And then human translators did the actual translation, but our system was the gateway sort of interface between the outer world of clients and the corporate, the backbone system that ran the translation operations. So that was cool, API centric. And now for about 4 years now, I've been with MassChallenge. They're based out of Boston. They are basically a global network of startup accelerators. We've got permanent accelerators in Boston, Houston, Mexico City, Jerusalem, Switzerland, and they run shorter term ones other places too, but those are the ones that are always on. And in Boston, there's also 2 vertical market ones, one for health tech and one for fintech, which is money. If you don't know what fintech means, I didn't. And they have a Python application that's sort of the backbone of their operations. So entrepreneurs create accounts, and then entrepreneurs put up a profile of their startup, and they submit it to one or more accelerators. They get judged, they get admitted, etc. This is all happening on the platform that I build with my team. Once they're in, 10% of the applicants get in, they can coordinate meetings with the experts in the pool, which is really kind of the value prop for the business. Is we have a pool of 1,000 mentors who are experts in finance or HR or regulation or what have you, the thing that your startup needs to sort of get to whatever the next level is. It's a fun job because there's this incredible diversity of excellent startups. Like I said, 10% get in. So any random startup that I happen to contact with through MassChallenge is just predetermined to be exceptional. Oh, we made a sterile operating room in a backpack for military surgeons. Or, oh, we made we have we're revolutionizing palm oil farming in West Africa to be cooperatively owned, or whatever. That people are doing cool stuff, and the platform supports it. So it's a fun biz, and some of my code samples will be from this as well. All right, hope I kept that down almost within limits, not quite. So Python 3, it's been around for a while. You might, if you're a Python person, I keep forgetting how long it's been around. 2009, believe it or not, Python 3 came out. Quote unquote, nobody used it for a while. I would say up through 3.4, it was a little bit of a dicey proposition, not just because it introduced a lot of breaking changes, which it did, but because there were things missing, and there were rough edges on it that were significant sort of obstacles to people adopting it. That pretty much, by the time 3.5 came out, and definitely by 3.6, that was just no longer a good excuse for not using Python 3. And the good excuse was it's too hard to migrate our code. You know, legacy code is production code. And so if you've got any functioning Python, you are loath to touch it to turn it into Python 3, even though it's ostensibly not a big change. So here we are with Python 3. In case you sort of didn't get the sort of top line items, one of the major things with Python 3 was cleaning up Unicode and string handling, which just became increasingly important, especially with, you know, in the period from 2005, like the 5 years before Python 3 came out. Python was growing hugely in the web space. Django and Flask and Web2Py and a few others had made it an actual going concern in that space. And web work is really all about dealing with strings, and strings from foreign sources that might have different encodings or other mysteries. And it's not magically better when everything's Unicode, but it removes a whole bunch of ways to shoot yourself in the foot. So that was one of the top line things. And it was intentionally a sort of breaking change in the language because certain things just couldn't be made backward compatible, which I think was smart. There's definitely people who are upset about what changed. And I know at least one person who stopped using Python because they didn't change enough stuff. He was hoping for something more radical, but I think they did a good job. As I was mentioning, it's a lot of work to upgrade. This is just a snapshot from the epic that we did at MassChallenge when we were moving our code base to Python 3 from Python 2. It's about 100,000 lines of Python, and it's been around since, I think it was, the first version was created around 2008, 2009. So it had old crusty bits, none of those people are around anymore, and it was time to move. So anyway, I led this upgrade, and that taught me a bit about Python 3, but that mostly was about things like this. This is about, here's all the things you'll see when you run your test suite for the first time on your code base when it's running on top of Python 3, when it has been running on top of Python 2, mostly string encoding related errors. So we have about 2,000 tests in our unit test suite, about 600 of them through errors when we switched to Python 3. They didn't fail, they just couldn't run because they weren't prepared for the world of Unicode. So that was a big project which we succeeded at. So now we've got things running on Python 3. So I'll jump into the things. This is sort of the what did you miss, my silly title for the talk, in terms of what might have come in the door with Python 3 that you didn't catch. Because Python 3 spent so long in the shadow of Python 2. I mean, literally, it came out in 2009, and Python 2 wasn't end of life until a year ago, January. So there were 10 years there where you could kind of choose either. And most people chose Python 2 for the first part of that, and the uptake was slow. So it was easy to miss the things that were new because most people focused on the things that were the same because that's what enables transition from one to the other. So I'm just going to run through some of the stuff that I think is neat in Python 3 with a few caveats along the way. And like I said, pop your hand up if you got any questions in the flow. I'll also give you lots of time afterwards for questions and discussion. But if there's anything I put up here or you see a bug, let me know that, you know, with your hand that I can help you out. I'll tell you also with each feature when it came into Python, just because I found that helpful. More or less, how long have I been missing out on this? And in some cases, you have your new Python 3 infrastructure is tied to a specific version too. And maybe you're in Python 3.6 for a while and you can't use things in 3.7 or 3.8. So that's another reason I mentioned the version. So the walrus operator, as it's called, because it looks like a walrus's nostrils and 2 tusks, came in Python 3.8. Actually, it's pretty new, somewhat controversial, but it made it in. And so here's some sample code. This is sort of sanitized code from my pastebin, and it's code from a part of the code base that's counting the objects in the database. So in short, if there's 100,000 things in the database, asking the database to count them just when you want to know the total, it takes a few seconds and it's not something you want to just repeatedly do. So I cache it. So this code, I'm just going to walk you through what it does because the sort of steps are important when we look at the version that uses the walrus operator. So you notice no walrus operator here, right? We set what the cache key is, and then we fetch from the cache. And if there's nothing in the cache, then we do the expensive counting manually because we need the number. And then we save that number in the cache. And either way, we print it. Okay, so there's basically 5 lines of logic there to do that, what I described. And the last one is just going forward and using it. Here's what it looks like with the walrus operator. This is pretty dense. I can't quite defend using the walrus operator twice in one line, but it worked. So what the walrus operator does is it's an expression. So you'll always see walrus operator expressions enclosed in parentheses. And it does 2 things. It acts just like the assignment operator, so that the name on the left-hand side is given the value of the expression on the right-hand side. And the parenthetical expression returns a value as well. So if you read this from the inside out, the cache get call says, get the cache entry for object count. And while you're doing that, set the variable object count cache key to object count. So there's 2 really different things happening in that one expression. And then the outer one on that same first line in the after block says, get that thing from the cache and assign it to object count and return the value. Why do I want to return the value? Because I'm using it in Boolean. So I care about the value of that whole expression, which is ultimately the value of the cache get. If it's not true, that means that implies that it's none. It's probably none, and therefore I want to set the cache. So that second line, the inside of the if, is a cache set call, and inside it, I've got object count being a walrus operator assigned to the value of do expensive object count. So the expensive call that I'm avoiding by the cache is do expensive object count. I'm doing 2 things with that. Inside that parentheses in the cache set call, I'm running that expensive operation, and I'm assigning this result to object count variable because I need to return it, whether I got it in the first line from the cache get operation, or I got it in the second line from the call to the object count. I still need to return it because the code that goes on needs to use that value. So this is an example of what the walrus operator sort of gives you and costs you. I'm a big fan of looking at engineering in terms of trade-offs, and I think the benefit is concision, and the downside is readability. It's most people, especially people who've not been reading a lot of code with this operator, would say the first code block reads easier. I would agree. And I'm still in early days of using this operator, and I for some places it's just nice to have 2 lines instead of 5. That's nice if you're in a module that's got hundreds of lines. But the expense is you've created a sort of density. It's not very Pythonic. Python is very much about readability and simplicity and doing things one way, and this sort of gives you another way that's not as clean and easy to read. I suspect this was some of the source of the contention over introducing this feature. So that's the walrus operator. Moving on to the next thing. Advanced destructuring. So destructuring in a simple form, it exists in Python. If you have, let's say, a tuple of 2 items, you can assign a comma b equals your tuple, and A will get the first item, B will get the second, which is cool. The advanced destructuring bit that was introduced here in Python 3, so this is pretty old actually, though it hasn't been used a ton in code I've seen, is this star operator, which is seen in other contexts in Python. It basically means expand this into a bunch of variables, can be inserted into an assignment. And so you see from this example, what happens is I'm saying A and B and however many other values are left, assign to rest, take the values from the whatever the right-hand side of the expression is, which is that list. So rest becomes 3, 4, 5 because A and B took the first 2 values. So that's a pretty simple, straightforward application of it. Just to keep up the theme of it's possible to go too far with this, I also encountered recently a hack for turning a generated expression into a list. So you could just, if you need a generator to turn into a list, you can wrap it in list, parentheses, and then you get a list. I was following a thread online where somebody for some reason didn't want to do that, and they had come upon this hack, which is if you put your star named variable in square brackets denoting a list literal, it turns the right-hand side of the expression into a list. So this is a very esoteric thing, and I think it's for somebody who's trying to save characters, which is not a very Pythonic thing either, but it's possible. And so if you ever see it, you'll know. You won't have that expression, have that feeling that we sometimes have, which is that legal syntax? And then you go try it out and confirm it is, but you have no idea. Keyword only arguments. This is a thing that I like a lot because I'm a big fan of making the APIs of functions really hard to mess up and explicit. And that means using the names of arguments when you can. So, functions that take a lot of positional arguments, I don't like because they're very opaque. Sometimes it's clear what the sequence should be naturally from what it does. Sometimes it's not. And so the keyword only arguments, what it does is it gives you a syntax that lets you say these have to be specified by name. You can't just put them in positionally. In Python, otherwise doesn't care. You put in an argument and either you put it in the right position in the sequence of parameters or you specify its name. So the magic sauce here is that little asterisk inside the function call. That very first argument is an asterisk. This in the definition of the function signature, which means it means that's all for the positional argument. So if we had positional arguments, they would come before the asterisk. We don't. For this example, I only wanted keyword arguments. So the asterisk denotes the end of the positional arguments and the beginning of keyword arguments. So everything after it in the argument list has to be specified by name. So you see that if I try to call that add prefix function with the 2 parameters, it takes 2 parameters, I give it 2, obey me, it complains because I didn't do it right. The function signature demands keyword names for the arguments. Also, can anyone tell what it's not a bug exactly, but there's a gotcha in the function that my example is intended to highlight. If the example did work positionally, the returned text would be me obey, which was not what the person calling it with obey me was probably going for. So I just put that in as a silly way to make the point that keyword only parameters can save you from function signatures where you could mess up the order and really mess up the semantics of what you're trying to do. So that's keyword only arguments. F strings, not that kind of F strings, but this is yet another formatting technique available in Python. Some people feel there's too many already. We have the old style % formatting, then we have the dot format method on strings, and now we got another one. I agree, it's kind of excessive to have so many, but you can't just delete the old ones when a new one comes out. I like F strings quite a bit because they are they're more compact. There's less syntax around them. So in short, what the feature does is if you prefix a string with an F, just like B for byte strings or R for raw strings, it's treated specially that anything in curly braces is looked up as a variable name in the local namespace and interpolated. So you see that the first example is real simple. I've made 3 numbers, A, B, C, and then I print the F string with curly brace A, B, C inside it, and those get interpolated. And there's various formatting specifiers that are all in the Python docs. So you can do things like specify how many digits of precision you want on floats, that kind of thing. And then my last example has a sort of comparison with the format method as an alternative way to do it. So, and it also illustrates the fact that you don't just have the power to reference variable names, you can actually make function calls. So this is where, does this remind anybody of anything that they might not want to be involved with too much? PHP, did you say? Yeah, it reminds me of PHP quite a bit too. I'd rather not be making function calls inside strings. I feel a little weird, and also it doesn't look as clean, but it's useful. And the format method syntax has a gotcha in it, which is that it doesn't complain about additional parameters. So it's possible to get out of whack without realizing it. So in other words, in that format call, if I had a 4th parameter, and let's say I had inserted accidentally something before the 3rd parameter, and so the 3rd had gone 4th, it would basically disappear from the string, and I might be kind of puzzled in debugging why it wasn't showing up. Whereas in the F string, the identifier name is literally there inside the string, and either lookup's going to succeed and give you a value, or it's going to fail and give you an error. And the percent formatting, the older style of interpolation, has its own gotchas too that were the reason that dot format method was added. So F strings have fewer sharp edges and are more sort of cleaner syntactically than the alternatives. So I'm in favor of them for that reason. Here's another one. I didn't know about this one until recently. This came in only in 3.9, which I'm running in production for my pastebin site, but we're not using it at MassChallenge, so it's not on my radar. But this is just a nicety where you can join dicts together with the OR operator, which is used for sets, but it wasn't available for dicts. And so the examples make it pretty clear. You can, if you have 2 dicts, and then you use the bar to, it's called union. It's a logical or a bitwise OR normally, but if you use it with dicts, it's a union operator, and it gives you the union of the 2 dicts. It also, for some reason that you can't do this with just the union operator, but the union assignment operator in the last example there can work with lists of pairs, key value pairs. That's what you get out of, let's say, an iterator, the items method on a dict. You'd get a list of, or really an iterator of key value pairs. Those can be used as input to the union operator and be added into the dict as key value pairs properly. So that use case has an appeal to me. Again, it's concise, and it's nice to have less verbose ways of dealing with data structures. So I like that. All right. What? That wasn't the last slide. Hey, what the? I got some key bounce problems here. Now you're seeing all my secrets. All right, let me go back here. I don't know how that happened. There you go. Phew. Speaking of secrets, this is a neat one. This also is newish. It came in 3.6, and there's already a random module in the standard library in Python. That's not really for. It's not cryptographically secure. They say now that they have the new secrets module, they say that the random module is for modeling and simulation, but not security or cryptography. So the secrets library it's basically a lot of the same methods you have in the random library, but cryptographically strong. So if you're building your own XKCD password generator script, you can know that your 4 words are randomly chosen with cryptographic strength that's sufficient for the task. Also, and so I gave this a demo. So there's now a super strong password here that everybody should use in this talk because it's proven to be super strong and easy to remember too. So free bonus, free password. And then close to the end here, I got 2 more larger topics I want to hit. One is type annotations. This is a real favorite of mine. It's something that doesn't feel very Pythonic at first, right? Pythonic is a dynamically typed language. So we aren't used to having to say what type things are. Once in a while, you have code where you want to say, if this is an instance of that, then do this. If you have code that's polymorphic, or you have some other reason why you might be getting a parameter that's of more than one possible type, or you're checking for sanity's sake or for to prevent a crash that data is of a certain type. So we're used to that once in a while, but not as a mainstay, and it feels kind of like statically typed languages that we don't, if we're Python people, we tend not to have much truck with C or Java or languages where you have to specify the type of everything. Well, type theory has come along and implementation has come a long way since C was created in the early 70s. And the Python rendition here, it's very soft. For one thing, the language actually still doesn't have any enforcement of this. So you can annotate your types all you want. The syntax is there. Nothing in the language deals with it. So you won't get any new errors from this. But what it does do is opens up the door to tools. MyPy is the most common one that read the annotations and do complain if something's out of whack. So here's a method. This is a modification of a method from my pastebin that I'm using as an example. And this is more or less real code in the pastebin. And one of the features is people can say what their rendering theme is, and this view fetches it if the user has specified it. So the annotation, the only annotation part, the only Python 3 part here is that this right arrow and the type after it say what this function returns. That's it. So between the end of the function signature and the colon, I put in the arrow and the type. So I'm saying it returns a string. Take a look at this code and tell me if you think the type signature, or just tell yourself, is the type signature accurate? Let's presume that settings.default pigment style and request.user pref pigment style are both going to be always strings. Does it look safe? Pretty good, right? Would it pass your code review? Would you look at this and say, sure, that seems seems accurate? Let's run it through MyPy. Missing return statement in this function. So it checked all the files, and every time it found an annotation, it did all its super genius calculations as to what inputs were coming in, what were getting returned, etc. Missing return statement. I've got 2 return statements. How many do I need? If we were in a room together where people would just pipe up, I'd say, what is it that I'm not returning? I'm not returning a string if neither of those conditions are true. So my logic in the function is, if the request user is anonymous, return the default. If there's a user attached to the request that's truthy, then fetch their preference and return that. But it's possible that neither of those are true. Maybe the request.user is null, but that's not anonymous, or is some other empty value that doesn't have that preference and doesn't return a true, then the function will fall through. Now, this is a thing that Python does, which bites you from time to time, which is if there's no specified return, the function just returns a none implicitly. That's what the missing return statement means, is you don't have a return statement for that fall through case. If I did, and it returned an empty string, then MyPy would not complain. So here's the here's the fixed version. It's very simple, and this is the version that's actually in production. it just always assumes if the user is not anonymous that they are logged in, and that's the proper response. So MyPy could have saved me there from a situation where by some fluke that I hadn't ever seen or couldn't have predicted, that .user was present but falsy, and my code would have crashed. I have a running list at my job of bugs that we encountered because something was none that we never thought would be none, and this would be in that bucket. All right, I've got only 5 minutes left, and I want a little time for questions, so I'm going to accelerate a little bit through my last 2 points. Just one other note on type annotations. You can specify pretty fine-grained types. You can make your own types. You're not stuck just with the standard library that's sort of built-ins. So in this one, I've got a function that returns a dict with both a Django model instance and a string that describes the location of where the person who posted it is from. And that item with geo line at the top is what creates this type. Typed dict is defined in the typing library. So from typing, import type dict, and then you get to just specify that thing. And the optional on the return, you notice it doesn't, I don't say it returns an item with geo, I say it returns optional. That means it might be none. So this is the type annotation system giving you the way to say it might be none, but you got to say it. You can't just stumble into it and have it crash your system. You have to acknowledge up front, I know this might be none, and that's okay. So that's true in this in this case. There's possibility that that it might just not come up with something for sure, and that's okay. And async await, I'm not going to have a lot of time to talk about this, and this is a pretty esoteric thing, but it's a cool addition. Async programming obviously has come into vogue a lot, especially with Node.js and V8 behind the scenes of a lot of web properties now. And Python has had some stuff in that area, but not strong. And now it's got a really good async await library. And in short, this code does this. The key bit there is in the main method that gather is assembling workers basically that are going to consume the work queue. And so I put 10 numbers in the work queue, and I have 2 workers with different latencies. So this might be something like a web scraper. Let's say I'm hitting every URL in a list of 100 URLs, and whenever a worker gets the result, I want them to add it to the collection. And they're going to happen at different speeds, and I don't want to just block my code on every request while it goes out to the network and wait for the server to respond. I can just say fire it off, and when it comes back, then you deliver your results, and that's what's happening here. And so in the output, you can see that the fast worker gets through a lot more work items, and is able to because it's the slow worker is not blocking it. The slow worker is just chugging along and picking up a work item when it can. So that's my criminally low detail intro to async IO. But we've got a couple minutes left, and I just want to give a chance to anybody who had a question or comment or anything else, or you can tell me what you're doing with Python, which I always love to hear, even if you're just learning it. If you're interested in data, if you're interested in web, anybody, it'd be great to just hear that, because that's actually a good question. If anybody could pipe up who's interested in Python because of data, machine learning, AI, that kind of stuff, where NumPy, Pandas, and the sort of big footprint Python libraries are taking hold. That's a big force in Python that wasn't true 10 years ago when I was doing when I was really sort of peaking in terms of web work. The data stuff was just starting. Now that's a real big force in Python. Nobody? No. All right. If there aren't any questions, I'd be happy to say get on to your next thing. But thank you everybody for coming. It's really a pleasure to be here and to be able to pass knowledge on. And if you have any questions at any point, look me up. My contact info is in the Nerd Summit schedule, and I always welcome email with questions or anything else. So take care, everybody. Gabe, thanks for operating the controls there, and have a great afternoon, everybody.
Thank you.
Cheerio.